Hello there, how are you? So let's do a power flow on a Python library PyPSA. So I'm creating a series on PyPSA. So you will get a bit tough examples in upcoming series tutorials. So in this tutorial you're gonna see a very simple load flow, okay, from using the PyPSA library. It's a very good library for doing the power system analysis. So let's get started. So first we're gonna import the PyPSA here. Okay, so I just imported the PyPSA, and then after importing PyPSA I have to create a network, a power system network. So for that network, uh, okay, let's create the sections. It will be easy for us. Okay, so network equals to PyPSA dot network. So it will initialize a network. Now after initializing the network, we can add the buses, loads, uh, generators and all that. So first let's add buses. So let's add 5 number of buses here. So n bus equals to 5, and for adding all the buses in the network we have to do some iterations. So for in range and bus, we can add that buses each bus in the network. So network dot add, the name of that class is boss. So the name of the particular boss would be, let's say, boss number 0 1 2 3 4. Okay, so it would be a iterative number. So format I. Okay, so next for the bus we have to add the nominal voltage. Okay, nominal voltage. So for that, nominal voltage is not required actually, but it will be self-generated by the PyPSA. But still we can add it vnom as vnom, say 142 kV. Okay, so I just add a bus. Let's run this and check out the bus here. So if I do network does buses, then it should show me the buses. Here the v nominal, I just add here the v nominal. The x and y are the special coordinates for the buses. It will be used for plotting purpose, network plotting in the map. Okay, and all that. Let's add. Now we're gonna add. Let's add lines. Okay, transmission line. In this example, I want to use a radial type of line. Okay, radial type of line, that is 0 is connected to 1, 1 to connected to 2, 2 to 3 to and 3 to 4. So there will be 4 number of lines is for and range in bus means 1. So network dot add name of the class is line, and the name of the line is line number, let's say 0 1 2 3 4, send that for easy integration. Format I. Okay, so for line there should be a sending in and receiving in. So sending in is bus 0, that would be the name of the bus. Okay, so 0 1 2 3 4. For sending of 0, receiving 1. For sending 1, receiving to 2, and so on. So name of the bus is bus number, and it will be changed in each iteration. So format I. Okay, then receiving in will be bus 1 equals to bus number. Make sure your spelling should be correct for the name variables, for name, because the name of the bus once initialized cannot be changed. Okay, if you need to change, then you have to go manually to the bus addition. Okay, so dot format, it will be I plus 1 because it is sitting to the next bus line. So for transmission line you have to add a resistance that is 0. Let's say 0.02, x would be 0. Let's say 3. Normally r is greater than, sorry, x is greater than x in transmission lines. So this would add the lines. Okay, so if I run this, the network line has been added. So if I network dot lines, the line has been shown here. So I just ignored the B, okay, B part and G part, so conductance and the susceptance part, and the total, there are 4 number of lines here connected from 0 to 1, 1 to 2, 2 to 3 and 3 to 4. Similarly, let's add generators. Let's add generators. So first we have to add the slack generator. Slack generator. Normally slack generator can be added in bus number 0. For that, network dot add a generator. The name of the generator would be slack gen. Okay, so it will be add in bus 0, that is bus 0, name of bus 0 is bus number 0, and you can specify the power. Actually you can initialize it as a 0. Okay, p set equals to 0, and a must thing here is the control. Control is actually the slack control. Okay, so this add a slack bus in bus 0. So let's add another generator in some another bus. Network dot add generator. So this name would be my generator. Let's say generator number 1, and bus, add in bus number 3. Okay, let's add in bus number 3. So bus number 3, the P set, power set, let's say take 60 megawatt, and the control would be PB, right? PB, normally generators are PB. Then we're gonna add load. So let's add loads here. Let's add loads. So let's add a single load in bus number in bus. Okay, network dot add load. The name of the load would be load number 1, and the value of bus, the connected bus would be bus number 4 in last bus, and let's put the value of P and Q. P set, let's say take a 90 megawatt, and Q set equals to, let's say, 40. Okay, so you need not to specify the control here because the control will be PQ. So these are the additions here. Let's run the generator and load part. Okay, it has been added. So if I run network generators, so I have two number of generators. One is slack and another is P. And if I see network dot loads, so there will be only one load here. So the network has been completed. Okay, so let's run the power flow now. Let's run the power flow. That would be network dot pf. We can do linear power flow or the nonlinear power flow. Here we're gonna do the nonlinear power flow using Newton-Raphson. Okay, if I run this, then it has solved the problem in 2 iterations. Okay, so the solution has been obtained. Now we want to observe the results. Now for that, in Pypsa there are two type of components. One is static and another is dynamic. So if you run network dot generators, so type in there network dot generators, then it would say the static components. But if you want to see the dynamic component, generators underscore t. Okay, so it is the dynamic part. So you can see the slack bus is providing 30 and the generator first is contributing 60, and in terms of Q, Q is providing negative of 1.977, generator is producing 42, okay, MVAR. So if I want to see the voltage, then I would go for buses, network dot buses. So I want to see the dynamic part after iteration, that is underscore t dot, I want to see the voltage. The standard name is V mag pu. So the voltage results is here. So bus number 1 is 1, it is slack bus, so this would be 1. So the only voltage drop can be seen in the bus number 4 because the load is connected in bus number 4. And another thing is also the line flows. So how the line values are flowing. So for that you can do network dot lines underscore t dot p naught. Okay, for p naught. Sorry, oh, I mistake. Network dot lines dot underscore t dot feature. So this is the line flows. So these are all the line flows, how the line is loading, we can see from here. So this much for today. On upcoming videos I will show how to import from Excel files, and how to plot, and how to do optimal power flows, and so on. Thank you.